Again, welcome back to the workshop. For our last video on coloring a graph. The statement we made in the last video was something like that: a graph with only even numbered cycles, so cycles of length, even number, then that graph could be colored with just two colors. But the statement that we can actually make is a little bit stronger than that. A graph can be colored with only two colors whenever there are no odd length cycles. This is a stronger statement because this includes graphs which have no cycles at all. For the example we'll consider here, we of course do have cycles, but if we were to check each and every one of them, we would notice that each of them have an even length. For example, here is a cycle of length 4, and we could come up with a longer cycle, I do believe. Yep, let's go with this one up to here, down, up, over, down, and back to where we started. I believe that was length 6. So we have cycles of even length. No matter which cycle we try to make here, they would all be even length. And because of that, we know we can color it with just two colors. And we're going to use the breadth first search algorithm to help us do that. And how does that help us? Well, think of it this way. If I were to consider this vertex and then find the distance of every other vertex from that one, if I had two vertices which were even distance away, then those two vertices could not be adjacent to one another. And that would allow us to label all even vertices with one color and all odd vertices with a different color. We'll take more of a look at that as we finish this up. But let's start by applying the breadth first search algorithm to this graph. To help us out, we should label each of the vertices. A, B, C, D, E, F, G, H, and I. So we have given a basic label for each of the vertices, a way to reference them. And next we want to label each vertex with how far it is from some vertex. Let's choose A. So how far each vertex is from A, and which vertex would come before it in the shortest path. The predecessor piece of this doesn't really matter. We would be able to complete this without that. So A, of course, is a distance of 0 from itself, giving us that D is a distance of 1 from A, and that G is a distance of 1 from A. And then we have the adjacent vertices here. B is adjacent to both D and G, so it's a distance of 2 with predecessor D. And we've got H is a distance of 3 with predecessor D as well. Oh, I'm sorry, not 3. I want a 2 there. Distance 2, because it's adjacent to 1. And let's see, that gets us everything adjacent to the 1s. Now I can look at the things that are adjacent to the 2s. So E is a distance of 3, increasing the index there, increasing the labeling by 1. And then that is adjacent to both B and H. B, of course, comes before H. I is also adjacent to both B and H, so it is a distance of 3 with predecessor B. And we have F, a distance of 3 with predecessor H. And then the last vertex that we have to label has a distance of 4 from A with predecessor, let's see, EF. That would be predecessor E. Excellent. So the next thing that we can do is we can assign to these each a color. So I've already used yellow and blue. So let's use red and green. If you're red-green colorblind like I am, I apologize. All right, so to all of the evens, I'm going to assign red. Even, 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 even. to all of the odds, I'm going to assign green. Green, and green. So we can see that this has worked for us, right? Red is adjacent to green, red is not adjacent to any other red. So this works out very nicely for us. But how did this work? How does this really work for us? Well, what it does is if we were to consider the distance away from A, so H is 2 away, and C is 4 away. If I were to travel back to A, then I would have an even number of edges. And if I wanted to connect those two, they could not be adjacent to one another because that would give me an even number plus 1 is an odd number, which would mean we'd have an odd cycle in here. But there are no odd cycles. So that, again, that's why it works. That's the last example for this section. Again, we can use the breadth-first search algorithm to color a graph which we know has only a chromatic number of 2. Have yourselves a wonderful day.